we explored why chemical reactions happen. Now we're going to explore the main factors that affect the rate of the chemical reactions, starting with number 1, temperature. Temperature affects both frequency and effectiveness. It is defined as the average kinetic energy of particles. Kinetic energy is proportional to velocity, yada yada yada, physics. So the faster a particle moves, the more likely it is to smash into another particle.
This can be demonstrated using food dye and water. If I add blue dye to yellow water, it'll turn green. Temperature is going to affect how quickly it turns green. The water on the left is cold, the water on the right is warm. Note how much faster the dyes are mixing in the warm water. That's because the molecules are moving faster.
So that covers frequency, but what about effectiveness? Recall that for a reaction to happen, the molecules need a minimum energy. If they don't meet that minimum energy, so if they're moving too slow, they're not going to react. Next up is surface area. Surface area affects frequency. Chemical reactions only happen at the surface. The greater surface area exposed, the more particles can react. It's sort of like if you have an apple and it's getting brown. Because the browning only happens at the surface, if you have more surface area exposed, it's going to get brown a lot faster. But what about solutions? They don't really have a surface area. For fluids, that is, gases and liquids, we consider concentration.
If two of my friends are running around with their eyes closed, the chances of them running into each other is low. If you add more people, the chance of a collision increases.
Next up is the nature of the reactants. The chemical nature of the reactants is going to affect the effectiveness. This has to do with the physical properties of the particles colliding, such as size, stability, electronegativity, other sciencey words. I like medical shows. I don't like soap operas. You could say that's one of my properties. If I'm watching Days of Our Lives, you probably won't see me react. But if I'm watching Grey's Anatomy, I react very strongly. Pressure. Pressure and volume go hand in hand. They are inversely proportional. As pressure increases, volume decreases, and vice versa. This affects the frequency in the same way that concentration affects it. But instead of changing the number of particles, you change the amount of space that the particles have to move.
My friends are still running with their eyes closed, but now they are more confined. Low volume, high pressure. But if we increase the volume and thus decrease the pressure, the chance of a collision is reduced.
Probably for the better. Presence of a catalyst. A catalyst will make collisions more effective, but what is it? A catalyst is a substance that increases the rate of reaction without itself being changed chemically in the reaction. It doesn't get used up. It does two things. It lowers the activation energy so the reaction can happen at a lower temperature, and it orients the particles so they're more likely to have an effective collision.
It's like having an extra person in the room that can't be hurt by collisions. That person has a tendency to grab two people, help them collide faster, and also increase the chances of them
Getting hit in the face, i.e. an effective collision. So to summarize, affecting frequency is temperature, surface area, and pressure. Affecting effectiveness, that's a really hard thing to say, is temperature, again, nature of reactants, and the presence of a catalyst. I hope you enjoyed this webisode of Remi-Rix Science Chick. I'm your host, Remi-Rix Science Chick, saying go forth and do science. And check out the extra credit video in which I basically just blow stuff up. Well, kind of. I will demonstrate how these factors affect chemical reactions using simple household items. It's gonna be awesome. It wouldn't be the first time that I've been slapped for science.